Alright, today we're talking about speed and velocity. Speed is the distance an object travels over time. To calculate speed, you take the distance, whether we're measuring in meters, kilometers, centimeters, or millimeters, over time, which is the seconds or the hours. So here is the equation, S equals D over T. Common units for measuring. The SI unit for distance is meter. The SI unit for speed, and that means the International Science Units, is what SI stands for. For speed is meters per second or kilometers per hour or feet per second. But generally we don't talk about feet because feet is in the US customary system and not in the metric system. Or miles per hour. It's another common one. Okay, so the practice problem. Mike travels a distance of 18 meters. It took Mike 9 seconds. What is Mike's speed? Okay, so this is the equation for speed. Distance divided by time. So we plug in from the problem. He traveled 18 meters, that's our distance. And our speed was 9 seconds. So we plug in 9 seconds. And then when you have a numerator denominator to solve that, that means division. So we take 18 divided by 9, and you would show your math work over here. And that would end up equaling 2 meters per second. So we're looking for our speed. Our distance was 18 meters, and our time was 9 seconds. Okay, when you calculate average speed is the total distance traveled divided by the total time taken to travel that distance. So this is when we're combining like multiple trips. We're finding their average speed. Okay, and we abbreviate average speed as AS. And then the equation is total distance divided by total time. Tom drives 6 kilometers during the first hour of his trip. Then Tom traveled 8 kilometers during the next hour of his trip. What is Tom's average speed? So here we have 2 different trips. Okay, we want to find out what the average speed is. We know that average speed is total distance divided by total time. That's our equation. We know that the distance 1, the first distance that he did, was 6 kilometers. They told us right there. We know that the second distance that he traveled was 8 kilometers. And then we know that the first time he traveled for 1 hour. The second time that he traveled for 1 hour. So our total distance, when we add 6 plus 8 kilometers over our total time, and 1 hour plus 1 hour, that gives us that 14 kilometers. When we add 6 plus 8, that gives us 14. And then 1 hour plus 1 hour gives us 2 hours. Then to solve this problem, this is where we do our math work over here. You're going to be doing 14 divided by 2. Okay, you've got a numerator and a denominator, so that means we have to divide. Which gives us our average speed is 7 kilometers per hour. Okay, when you have your units for speed, it's always your numerator unit and then your denominator unit. Okay, the next thing we're going to talk about is velocity. Velocity is slightly different. Okay, velocity is a speed in a given direction. Okay, it's not just a speed like we were talking about. It's not just a distance and a time. It's a direction that you're traveling in. So like for this plane, its speed is 300 miles per hour, and its direction is west. That makes it a velocity because they give us the direction. Must have both speed and direction to know the velocity. Okay, so which of these are an example of a velocity? 25 meters per second westward, 1,800 kilometers per hour, 55 miles or meters per hour south, and 25 meters per hour. Okay, there can be more than one. Okay, you should have that A and c are both velocities because they have the speeds and they have the directions. Why is it important to know a tornado's velocity and not just its speed? Speed tells us the rate at which an object moves, but velocity tells us the speed and direction an object is moving. It's extremely important in the case of a tornado because if the weather people come on and tell us that it's traveling 30 miles per hour, and that's all they said, we wouldn't have enough information to know which direction it was traveling in. It could be north, south, east, or west. No one would know who needs to take cover. So it's important. That direction is very important. Okay, when we're plotting speeds, you will see them on a graph. Okay, it's always distance on the x-axis because it's independent variable, and time is the dependent variable on the y-axis. Okay, the further to the right on the axis, the longer the time is from the start. Okay, that's how distance and time graphs work. Distance is plotted on the y-axis. It's the dependent variable. Okay, the higher up the graph, the further from the start. So the higher up you go, the further distance you are away from your starting point. So think of this origin here as your starting point. Okay, here is a demonstration of a distance speed graph. It has a horizontal straight line. That means that over time, the distance is not changing. Okay, so this line is not moving. Time is increasing, but the distance does not change. It is not moving. The object is stopped. We could say that it's at rest. Okay, another graph, this is one that demonstrates constant speed. Okay, it's angled straight lines means that it's at a constant speed. It's constantly increasing at the same rate. Okay, the time is increasing to the right and the distance is increasing consistently with the time. The object moves at a constant speed. Constant speed is shown by angled straight line on the graph. Okay, this is a double line graph. You can see that the dotted line is steeper to indicate that a larger distance traveled in a given time. In other words, this object is traveling faster than that object. Okay, distance increases faster. The dashed line shows the object is moving faster than the solid line. Both lines are straight though, so that tells us that they are increasing speeds, or they're at a constant speed. They're not changing. Okay, distance time graph review. A distance time graph tells us how far an object has traveled over time. The steeper the graph, the faster it's moving. A horizontal line means the object is not moving, it's at rest. And a downward sloping line means the object is returning to the start. Okay, and that's one we didn't really talk about yet, but that's right here. Where you see this line, it's going away from the distance, like its distance is increasing from its home, and then it stops moving for a little while, and then it starts returning back to that distance. This distance is decreasing, and it's starting to return back to the home.